Thank you so much, Michaela. It is a huge pleasure and huge honor to be here discussing my work with you today. In particular, I'm an economist, and I feel it's particularly honored to be here discussing my work with such a diverse group of people from various areas. I think I'll benefit a lot, in particular in this project, but more generally, to hear your various opinions about what we do and what we do not do when we approach the topic that I'm going to talk about from the economics point of view. So today I'm going to be talking about higher education and social mobility. This is joint work with Jack Britton, who is a colleague at the IFS and now is at York, and with David Gold, who is currently at number 10 Downing Street. And so to introduce this topic, I start by noting that children from low socioeconomic backgrounds, they are much less likely to enroll in higher education. That has been confirmed in various parts of the world through data analysis. And they are also less likely to make it to the top programs once they, even amongst those who enroll in higher education. And so really the aim of this project is going to be to try to understand why is it that there is this SES gap in access to higher education and in access to the most, the top programs, the most selective programs in higher education, potentially the ones that bring higher returns. And to determine, to what extent then this has impact for inequality over the course of life, in particular in earnings, and passes, and it contributes to past inequalities across generations. We will also be concerned with what can policy do about this, in particular if the concern is in promoting equal opportunities for all. So specifically, we are going to look at the following questions. We are going to try to understand and quantify what drives inequality in access to higher education by socioeconomic status. And we are going to try to separate different factors that may contribute to this different access, specifically the ones that come from the process of admissions from universities, so the extent to which the criteria that universities use to select students may not favor students from poorer backgrounds, potentially because they come with different sets of skills or with other characteristics that are not favored by the programs or by universities. And we are going to try to separate those from those that emanate from students' preferences or choices that can be determined by how much they perceive to be the gains to higher education, which may be different for students from poorer backgrounds than for students from better off backgrounds. But also, they may face different costs of assessing higher education and of studying, or they may be differently sensitive to the costs of higher education. So even though the costs may be the same, students from poorer backgrounds may respond more strongly to these costs, and so shy away from participating in higher education. So that's on the determinants of participation in higher education, and then we are going to try to see, okay, so given that we have these patterns, what are the consequences of these for future inequalities in earnings? Taking into account that these patterns reflect the fact that students choose very differently whether to participate and where to participate, and because they have different characteristics, we want to separate the parts of these inequalities that come from their predetermined characteristics when they assess higher education from those which are a consequence of the sorting patterns in the higher education sector. And finally, we can look at higher education policies, both those affecting demand for higher education, so affecting students' incentives to participate, and those affecting the criteria used by programs and courses to select students in trying to discern, which policies work and how do they work and to what extent can be implemented. So these are for the project, these are the questions that we are addressing. Today, actually, I'm going, given the time, I'm going to address mostly the first two, though, if I've got time, I can talk a little bit about the third as well. Okay, so as I said, aim is going to be to investigate the gaps by socioeconomic status in access and in the returns to higher education. and the consequences for inequality and policy. And what we do in the project to actually, explore this topic is first, I'm going to start by documenting the patterns in the sorting of higher education. I'm going to use the English case, so it's going to be data for England in particular. And then I'm actually going to build an economic model. I'm sorry, but that's the approach we take in this project in particular. I'm not going to focus, with much detail on the characteristics of this model, but it is an empirical model, but one that tries to formalize the preferences of students and separate those from the criteria that universities use to select students. And then a model that follows students over the life cycle. So, once they have finished their education period or time, they will go into the labor market. Their earnings are going to depend on their own characteristics, but also what they studied at university and where they studied at university, because we are going to consider this multitude of programs, and these programs may bring different returns and bring different returns to different students as well. So we are going to consider that fine detail in terms of characterizing the heterogeneity, the differences in earnings of different students who studied different programs. And so it's essentially characterizing these returns to education to that level of detail. To do this, we are going to exploit rather rich data. Now, I actually, all my life have worked with survey data, in particular with the Understanding Society a lot, and continue to work. But in this case, survey data is not going to be rich enough, and in particular, it's not going to have the numbers that we need to do this type of characterization. It's richer in terms of information, but the number of observations is relatively small and doesn't have the same type of information that we have in admin data, which is what I'm going to use. I'm going to use admin data for England, essentially providing information both on what students study, and so on that sorting in the higher education market, and also on their future earnings. And I'm going to tell you a little bit more about that data in a minute. But what that data is going to allow me to do is, it is rich enough in terms of information to provide variation that I can arguably assign to, potentiate the differences across students in their preferences for different types of programs and for participating in higher education from the criteria that universities use to select students. Once we've got this model estimated on these data, then we can use the model to try to characterize these inequalities and how they are transmitted across generations. We can also use the model, which is something that we sometimes do in economics, to do counterfactual analysis, to simulate what would a policy with different characteristics do to change, in this case, the sorting of students into programs and their returns in the labor market. So that's, it's sort of the use of the model later on. I'm not going to tell you about the sort of literature background that we rely on. We draw from actually, vast literature. This project is at crossroads between different topics that have been studied in economics, and I'm sure in other topics as well. You will be able to tell me about this. In particular, I'm just going to tell you that, there is a huge literature on the returns to education in economics, and a growing literature on, more specifically, returns to specific higher education programs. So distinguishing between the different topics that the fields that students study, and different universities providing these courses. There is a smaller literature, but also non-negligible, trying to understand what drives students to choose whether to study and what courses to study. This typically takes the view of the student making the choice and is less concerned about the constraints that the student may face in terms of whether they are going to be accepted by the program of their choice. So there is now a very small literature actually considering these constraints as well, that students, may prefer to study, say, physics, but they may not be accepted in a physics course. How do you actually consider the characteristics of this market, which is going to impose constraints on the choice of students? And that's why we are also going to contribute. And of course, there is also some literature looking at policies in particular and how they affect the sorting of students into higher education, which we draw from as well. So it's a vast literature, with different levels of contributions in the various aspects of it, to which we contribute, but on which we draw actually very heavily from. Okay, so given this, let me start telling you about the data. We are going to rely on these admin data, the longitudinal educational outcomes. This is data that is provided by the Department for Education here in England. It actually merges together three sources of administrative data. The first one is the National Pupil Database, which follows students over their education school life. For each student in UK, so for the universe of students, we can identify them, longitudinally, so they have their sort of unique ID, and we know which schools they attend. And because we know which schools they attend, we also know which other students are studying with them in the same school in the same year. We know the location of their school. We have test scores for all the national tests that they have, say at age 11 in particular, at age 16 for GCSEs, and then at A-levels. And we don't have very much information, demographic information on these students, but we know their gender, we know their age or their cohort. We know their ethnicity, the place of residence, and we don't have a lot of information about their socioeconomic status. But what we do have is, because we have a very detailed measure of location at the lower super output area, which is small, there are many in England. We know for that area the index of deprivation that is calculated in particular for young people, IDACI. And we know whether they attend a private school or a public school. So this is the information that I'm going to use to gain detail about the socioeconomic status of the students. Rather than a sort of individual level data, it's going to be information about the small neighborhood in which they live. Now, that National Pupil Database is going to be linked to ISA data from higher education. So this is data about all higher education providers with details for each student. So we follow students into higher education, and it details for each student which university and field of study they enroll in if they move on to study in higher education. So we see their enrollment in these courses. And again, this data now is going to be linked to tax records, which once the students finish their education are going to report their annual earnings. So we do not observe details about their employment, but we know whether they are working or not because we have earnings through tax records. So this is the information we are going to use following students over time. We are going to focus specifically on the cohorts born in 88 to 91, so 4 years, essentially 4 cohorts. They are graduating from high school between 2006 and 2009. So accessing higher education just before the big reform to tuition that happened, that was implemented in 2012. We've got about 2.5 million students in our database. About a third of them enroll in a 3-year university course here in England. Okay, so given this data, let me tell you about how we characterize programs and how we characterize students. The 2 parts of this market. I'm going to consider programs. So there are many. I'm going to consider essentially 2 characteristics of programs. One of them is the field of study, and the other one is the university providing them. On the field of study, I'm going to aggregate programs in 3 main fields. LEM, which is Law, Economics, and Management, STEM, the sciences, engineer, medicine, and math, and humanities, which also includes arts and the other social sciences except for economics. So that's the 3 big groups that I'm going to consider. There's been a lot of discussion on whether we want to go a little bit more in detail on the fields of study, which is something that we can consider. But for the time being, these are the 3 that I'm going to consider. On the university side, I'm going to consider all 150 universities that provide higher education in England, which means effectively, because most universities are generalists, that I'm going to consider 450 courses supplying places for students to select into. Now, in characterizing the courses, these 450 courses that are on supply in England over this period, I'm going to consider as a summary measure of the quality of the course. And I call it quality. It's an index that we constructed from information from the Complete University Guide, which essentially provides a league table for UK universities. And it has details, so it's essentially the first principal component from an analysis of 5 quality indicators, which includes spending in academic services and facilities, the research quality, the student-faculty ratio, and student satisfaction. And what I'm going to try to show you is that this index actually captures the selectivity of the program, and it's highly correlated with the quality of the students that the programs take. Okay, so this is on the higher education programs. On the students program, on the higher education side. On the student side, we are going to consider the skills that students bring when they apply to attend university. So we are going to consider specifically 2 dimensions of skills, and I'm going to call them communication and quantitative skills. And the way we are going to build these measures of skills is by using the test scores that students hit at age 11 and at age 16, which are about 12 measures per student. And I'm going to do a factor analysis essentially to build these 2 indices. And I'm going to ground the factors, the quantitative on math score at age 16, and the qualitative on the English score at the age of 16. Once I build these indices, if I scatter plot them, so using a random sample of students, what you see here, so here in the x-axis, the quantitative skills, and the y-axis, the communication skills, and what you see is that there is a huge, very high correlation between these 2 skills. Actually, the coefficient of correlation is about 0.9, which would beg the question of whether we actually need to consider 2 skills separately rather than one only. We argue, however, that these small differences in these skills are very predictive of which fields the students study. So here I'm plotting the field enrollment. So for students who follow up and enroll in higher education, I'm plotting the proportion of students enrolling in humanities in red and STEM in blue. For women and men separately, but the graphs are not very different. And these on the x-axis here, I've got the skill difference. So the math score or the quantitative score minus the communication score. And what you see is that, the differences are in standard deviations. And what you see is that a small difference, a small comparative advantage, as we will say in economics, in mathematical skills is highly predictive of the student enrolling in a STEM course rather than a humanities course. And this is true for women, and it is true for men too. And so it is really, sometimes really very similar students, but just because they score, their either communication or math scores are just slightly different, that will determine whether they enroll in one field or the other. So we think it's important to distinguish between the two. They are also likely to have potentially different impacts in terms of their earnings. Now, I told you about the qualitative index in terms of characterizing the programs, and I told you that we think that there's a good job of characterizing the selectivity of the program. This graph here tries to demonstrate that. It's again plots quantitative skills against communication skills, and here the scatter plot is the average skills of the students who are admitted in each program. There is a range of colors over here from red to blue, which indicate the quality of the program, and as measured by our index. And what you see is that the top programs over here are the ones who take students which are higher in quantitative skills and communication skills because of the high correlation. They tend to be the top courses in terms of our quality measure too. And you see how as you move down the skill distribution, the courses seem to be of lower quality according to this index. So we use this as evidence that this index is actually capturing the selectivity of the program, which is associated with students with higher scores selecting into these programs. Okay, so given this sort of sorting or brief characterization of the sorting in this market, let me now cross this with socioeconomic status. So I'm going to use the dark key indicator that I told you about that is recorded in the NPD with, crossed with a private education indicator to characterize socioeconomic status. And what we see, if you simply look at data and you look at the earnings at the age of 30 of the individuals that we observe in the LEO data, and we cut the data by quartiles in the SES distribution according to this index, what we see is that the gap between the top quartile and the bottom quartile in terms of earnings that's at 30 is about 31%. That is, the students from the bottom quartile earn about 69% of what the students at the top quartile of the SES distribution earn by that age. They are also less likely to be in work. They are 11 percentage points less likely to be in work by that time. And so our question is, to what extent can these differences be attributed to pre-existing inequalities that the students come from, so their different skills, or are they expanded given the sorting of the students into the higher education market? So one pre-existing inequalities may actually play quite a big role, actually do. So these graphs here show you how these students differ in terms of skills, and demonstrate that skills play an important role in the selection into a higher education. So here on the left, you've got simply the proportion of students enrolling in higher education here in blue by the skill percentile, and you see how there is a huge gradient in terms of the proportion of students enrolling. So the students with higher skills are much more likely. Students with skills in the bottom 40% or so essentially mostly do not go into higher education. As we've seen before, there is also our index of quality is always also highly predictive of the quality of students intake, with the average quality of the programs that students in the higher sets of skills being much higher than those in the lower skill part of the skill distribution. Given these, we of course will look at what are the differences in skills between higher and lower socioeconomic status students. And what you see is that here in red, the distribution of skills among the top quartile of the SES distribution according to our indexes, and in blue for the bottom quartile. And on average, there is a 1 standard deviation difference in the skills of these two groups. So the differences are quite large. But if these differences in skills do not explain all the differences, all the gaps in SES in terms of sorting into higher education. These graphs here demonstrate that. So here on the left, you see the gap in access to higher education across the skill distribution on the x-axis. And what you see is that there is little gap for lower levels of skills. That's because most of the students actually do not go to higher education, so there is no gap. But as the skills increase, the gap expands, and actually it's quite large for higher skilled students. So higher skilled students from low SES quartiles are much less likely to enroll in higher education than higher skilled students from high SES quartiles. And that's where actually the differences are the biggest, right? So about 15 to 20% percentage points difference. If they enroll, then what types of programs do they enroll in? And again, what we see across the skill percentile distribution is that the differences are very small for lower skilled students, but as the skill increases towards the top of the distribution of skills, even high skilled students in the low SES quartiles are going to have to join programs which are lower quality than the high SES students in similar skilled and who also join programs. So as you cut the data along the various dimensions, you see, the gaps still persisting across them all. So though skills might be an important determinant of these gaps, there's more to them than simply differences in skills. Okay, so that then begs the question, what are the relative importances of those various differences to explain differences in sorting in higher education and in explaining differences in earnings later on in life. Now, the approach I'm going to take now is to build this economic model. It is sometimes used in economics to try to understand, the data and the patterns that you have through the lenses of models that formalize the choices that individuals do, given the constraints that they face. And that's what I'm going to do here. I'm going to model the higher education market where the two groups of players come into contact. The players are going to be the programs who have places to be filled and that offer education, and the students who want to enroll in higher education and invest in their skills. So this model, what it's going to give me is to separate the role of preferences of students, so their costs and their expected returns from enrolling in higher education in determining their choices, from the constraints that they face because of the capacity constraints that these programs have in terms of accepting students. And then this selection program process, which I'm going to characterize, is then going to determine the later returns in higher education, given that these programs are heterogeneous, they offer different skills, and given that the students who sit them are also heterogeneous, they come with different sets of skills. All right, so the higher education market in England, I'm not going to go into very much detail about this. I'm just going to say that, we consider what most students do in this modeling. We are going to consider students apply to university straight after completing high school, which is the case for the vast majority of students. They either enroll on that year or the year later. They apply to a number of programs. We are going to consider that they can apply freely to any number of programs, but that they know roughly where they sit, and therefore they are going to apply to a subset of programs for which they have chances of being admitted. In UK, differently from in other countries, most students who apply to university and get a place, they actually complete their higher education. We are going to model being enrolling in higher education rather than completing the course. So the facts that we are going to measure are those of enrolling in higher education. The vast majority of students, as I said, will complete their program, but some of them won't. Now, we are going to consider that the programs have a fixed number of places and they charge a fixed fee. At the time for the time of our study, so for our cohorts, this fee was £3,000 per year. That's what we are going to consider. And the programs do not have flexibility to change these, so that's centrally regulated, both the number of places that they have and the fees that they charge. Rather than that, the market is totally decentralized. That is, the program sets the criteria that they are going to use to accept students, and they are free to do this as they wish. And then according to this criteria, they offer students places, and students are going to choose amongst the offers that they have their preferred choice, essentially. That's how we are going to model. As I said, students do have a limited choice of places of programs to apply to. The skill requirements of these programs are well advertised. The programs tend to advertise sort of the criteria that they use. And so we are using these to argue that they know roughly where they sit in terms of the programs to which they are eligible. We model the funding of higher education as it happened during this period from the point of view of students in particular. So they face no upfront costs in terms of participation. But they because they can draw on loans that cover their tuition and that cover, to some extent, their living costs. The repayment starts at work, which we also model. It's like a tax on graduates, and which applies from the moment they're earning above a given threshold. So this is going to be in the model. Okay, so let me just give you then an overview of the model. So this is going to be a model of the life course. That is, I'm going to consider the education choices of the students who finish high school. I'm going to then model their earnings and employment over the course of life, given that they have done whatever investments in education that they have done in the beginning of life. Model will also have consumption and savings, but we are not going to pay attention to that. And what I'm going to do is to split life in two parts. I'm going to say, at the beginning of your life, once you finish higher education, you decide how much to invest more in your education, whether to participate in a university program, and if so, which one. At that point, there is a market for higher education where the programs offer places. And then the second part of the student's life is their working life, where they work and earn, essentially. In that market for higher education is where sorting into higher education happens. And the sorting into higher education is then determined by the interaction between these two groups of players. The students who have preferences for studying different fields or at different universities, and the programs who have preferences for specific students because of the characteristics of the students. So, it's this interplay between these two sets of players that is going to determine, how students are assigned to programs. Okay, so how do we do this? Okay, we consider both the program side, or we model both the program side, or the determinants of the supply of places, and the student side, the determinants of their preferences. In terms of the programs, what we say is, okay, we are going to consider programs along the dimensions that I've characterized to you. So programs are in a specific field and given by a specific university and therefore associated with a given level of quality. And what they do, these programs, is they observe the distribution of students. In particular, they observe the skills of the students, both the skills that I have described to you, the mathematical skills and the mathematical skills and the communication skills. There might be also other skills that we as statisticians do not observe. I'm going to call them theta. We also consider this possibility. And they may have preferences towards other students' characteristics, particularly programs may have preferences towards the socioeconomic status of students or their gender, because they want to achieve, say, a certain combination of students. This is modeled, in this equation, which I'm not going to pay very much attention to, but the only thing I'm going to tell you is that these programs prefer students with given level of skills, so they like skills in general, and so they prefer more skilled students, both along dimensions that we observe and the dimensions that we do not observe. They may have preferences for the other characteristics of students too, and we allow these preferences for students' characteristics to be field-dependent. That is, a mathematical program, a course in masses will not prefer the same type of students than a course in English. So they will have heterogeneous preferences for students depending on the field of study. On the other hand, students themselves have preferences for programs, and these are a little bit more richer, because students not only have their current preferences for the programs because of how much they enjoy studying different topics, but also they foresee the returns of studying different topics, and so they have preferences for the earnings that these programs will bring them in the future. So this is how then we model the preferences of students. We consider students, again, that vary by their levels of skills and by other characteristics that they may have, say gender or SES. And their preferences for programs in terms of their current enjoyment of the program depends on the characteristics of the program, so the field and the quality. Students with different skills will have different preferences for studying STEM or for studying humanities, for instance. But there are other characteristics of the programs that students also value. One of them is distance from home. So students may prefer to stay closer to home or not, because this involves different costs in terms of attending higher education. They may be also influenced by what peers around them do, and so they will listen to what the traditions in their communities are in terms of studying at university and in terms of studying specific topics at university. So we are going to consider that as affecting their preferences or their costs for studying different programs in different programs. And so when we model the choices of students or the preferences of students, we consider that there is a current value of attending university and studying program F, so in field F, which depends on the characteristics of the program for the students, the quality, the distance, and the share of other students doing it, their comparative advantage, whether they are better in math or in communication, and other characteristics that they have, say their socioeconomic status. Also, they value future earnings that this program may bring them, which are here summarized by this term. Okay? And that's all about this that you actually need to know. So if we do this, and we then, bring in the data, all the courses and all the places that these courses have, what we can do is to sort students into the programs according to their preferences and according to the program's preferences too. Okay? Now, for this, it is crucial that, there are these capacity constraints. All right? And so what we do is, to consider that, there are no prices in this market that clear the market, which is the typical way economists see these problems. The market is going to clear because of these capacity constraints. The programs only have this many places available. Programs that are more desirable from the point of view of the students are going to set their threshold in terms of who to accept higher than programs who are less desirable from the point of view of the students. And this clears the market and gives us a sorting that can reproduce the data. Okay, I'm going to actually run over this pretty quickly because I've got only 5 minutes left. But later in life, students, once they graduate, they earn when they work. Their earnings are going to be a sort of a flexible function of their own skills, their their socioeconomic background, and the program that they have studied. So they are going to be field-specific, and they are going to depend on the quality of the program and all the interactions between quality and the skills of the students and the other characteristics of the students. So we allow for all these interactions so that we can separate on earnings, what comes from students' predetermined skill characteristics and socioeconomic background from what comes from the course that they studied. Okay, so let me not talk about how we estimate these so that I can show you some results. What do we find? So remember, we separate the role of programs and of students in determining who studies what, right? And what we see is that, skills are very important, we knew that, but over and above skills, from the point of view of the universities, the socioeconomic status of students is also very important. The students, the universities, over and above the skills that the students bring, they also value more students that come from high SES backgrounds, and in particular, students that come from private universities. And in specifically, the advantage of a student coming from a private university is equivalent to about 0.6 standard deviations in the quantitative skill, okay, which is huge, given that the difference between the average difference in quantitative skills between high and low SES students is about 1 standard deviation. That said, students also have different preferences depending on their socioeconomic status. So, even once we control for all the selection, for all the preferences of universities, we see that students from high SES backgrounds have higher preferences towards studying, actually all topics, but in particular STEM, and students who, in addition, come from private schools as well. So, even once we control for the skills of students, their sort of neighborhood characteristics, etc., it's still the case that socioeconomic status plays a big role in determining students' preferences towards education. And so, these will contribute to explain why they enroll less. It's also the case that students from low SES background are more sensitive to the costs of studying higher education. So specifically, for instance, look here at the distance, and this table here, these numbers show you, the expected earnings compensation for students from low SES to high SES to demand to study further away from home, in this case 100 kilometers more away from home. And what we see is that for students from low SES backgrounds, going further away from home, which in general allows them to go to a better place, would require almost 7% compensation in terms of future earnings, while that compensation is about 3.6% for the high SES students. Okay, so given this sorting and all the selection that goes on, is SES still having an impact on earnings? And given that you control for everything else, so you control for the skills, the characteristics of the programs, the selection that goes into it, and all these interactions. And yet, even after controlling for these, it is still the case that SES has a very large impact on earnings. Here we have earnings for non-university students, so for those who do not study, are about 30% larger for, the gradient is about 0.3 for ISES, by SES. The gradient is smaller for students who study, which means that actually returns to education are larger for low SES students than they are for high SES students. But SES, nevertheless, is an important determinant of earnings later on, despite all the controls that we have here. And these graphs actually show that. They show that both for women and for men, the returns to the higher education premium, the returns to higher education in the various courses that you can study, or the various fields, by SES index, and they show how these returns are lower for those in the top SES groups than for those in the bottom, because of these differences in the SES premium by level of education. Okay, so let me skip these to just finalize with these numbers. So one thing that we wanted is to decompose inequality by the inequality in earnings by the contributions of predetermined characteristics of students, in this case gaps in skills, and the sorting mechanisms in the higher education market. And so what we see, so here in this column here, comparing the bottom and the top quartiles of the SES distribution, we knew already that there is a 31% difference in earnings at the age of 30, if we decompose these earnings into these, in particular, two components, the predetermined gaps in skills and what comes from the sorting in the higher education market, what you see that about 40% of the gap comes from differences in skills, which we saw were quite large. But there is about 25% which comes from sorting in higher education market, given skills, so equally skilled students sorting into different programs that have different returns. Of this sorting, the major determinant is actually the criteria that universities use to select students, preferences of students, despite the fact that they prefer to stay closer to home, etc., etc. They only contribute with about 5% of about 5% of this gap. Okay, so I can finish here. Just to say that the model surely is a quite is a structural model. So there's a lot of assumptions there that allows us to sort of separate these preferences of students from preferences of programs, etc. But it actually fits the data really well. It fits also the effects of policy reforms that we observed afterwards. And when we use the model to gain insights into the likely impacts of reforms, we look at reforms that change the costs that students face into assessing higher education, in particular, for instance, by providing grants to poorer students or providing grants to poorer students who attend better higher quality courses or STEM courses, vis-a-vis policies that impose quotas on universities. For instance, we try out a 10% quota, which is similar to a program existing in Texas, which gives preferential admission to students that come from low socioeconomic backgrounds and who are high-skilled. When we compare these policies, what we see is that it's essentially quotas that actually move the needle. Once we've done this decomposition, it's easy to understand. It is really the preferences of students of universities, the way that select students, that are the most stronger determinant of how students sort into higher education, rather than the preferences or the constraints that students face. Thank you.